Okay, I hope you have gone through the problem, and in this problem there are two systems. Okay, there are two systems like this one. This is the system A plus C, and this is another system B. So I mean, in this problem probably we'll take A plus C as the same system. Okay, it's a rigid body, so there is no problem of taking this as a system, and this is also a rigid body, and the mass of this is m and mass of this is 2m. Okay, now there is friction. Okay, now please remember, never assume that friction is equal to mu mg. Many students do this mistake. Friction is not always equal to mu mg. Friction is equal to mu mg in a certain case when there is a limiting friction, right? So when two bodies are in acceleration, then obviously you can write F equal to mu mg. These two bodies are accelerating. I mean, if you have gone through this problem, this B is accelerating towards this, and this A plus C is accelerating towards this. Okay, so obviously in this particular case we can write F equal to mu mg. There is no problem, but it's not always possible. Like I said, that F equal to mu mg is possible only when the friction is limiting. That means if they are moving, probably we can directly write it F equal to mu mg. Okay, the frictional force is mu mg. Now let us draw the free body diagram of these two systems. Okay, this is the first body. So this is this body writing. Okay, so obviously we can write there is a tension T in this directions, and there is 2m mu into 2m into g. That is the frictional force. That means the frictional force is nothing but 2 mu m g, and this body is going with an acceleration. It's not necessary that two bodies are going in same acceleration. It's not. So this body is moving with acceleration a1. So what we can write, T minus 2 mu mg equal to 2m a1, isn't it? Because this is nothing but Newton's laws of motion, right? The net force, obviously T is more because this body is moving in this direction. So T minus 2 mu mg equal to 2m1. This is our first equation. Let's take this system A plus C. This is a single system, right? We'll take the rigid body A plus C, and this direction the tension is T because it's a light rope, so tension is equal. Only you have to remember this tension is working in this direction for B, and this tension is working in these directions for A plus C. And what else force is there? Obviously we can write, like I said, we can write directly mu mg because the bodies are accelerating. Suppose the acceleration is a2. Okay, so what we are going to write, you got it right, I'm quite sure, T minus mu mg equal to how much? The mass of this block is m, right? M a2. All right, so now we have to solve the problem, right? I mean, we have to now this a1 is given as a, right? This a1 is look at there. Okay, the B starts moving at acceleration a. So what you can write? We can write this as a. All right, we need not to write it as a1. Oops. Okay, we can write it a. All right, so we are writing. We have to find out a2 in terms of a. It should be pretty simple equations, right? I mean, let me get some more space over here. Can I get rid of this again? This is it. Okay, I'm getting some more space over here. All right, so how to get this a? We have to find out a2 in terms of a. So what I'll do, probably I'll subtract this one. I'll subtract 1 from 2. So what I'll get, mu mg equal to m a2 minus 2 m. All right. So we can comfortably cancel out. So what we are getting, a2 equal to how much, mu g plus 2a. This is something we are getting. Fair enough. So the accelerations of this body is mu g plus 2a. Now what to do? What is the question? That if the initial separations between two bodies is L, after find the time after which the bodies will collide. Okay. All right. So there is a bit difference over here. There are two bodies are moving in opposite directions. So what is this body? These two bodies are moving in opposite directions, right? This body and this body. So the net accelerations, just like if two trains are moving in opposite directions, then the velocities generally we add. Here also the net acceleration is what? A plus a1, which is nothing but 3 a plus mu g. How do we are getting it? We are sorry, this is, we called it a2. Okay, we are adding this, we are replacing a2 by mu g plus 2a. So the net acceleration or relative acceleration, whatever you like to call, is nothing but this one, 3a plus mu g, 3a plus mu g, right? So this is the net acceleration. Now what is that? What is the length they have to cover? The total length they are covering is L, right? So can I write L equal to half at square? I'm quite sure you know this formula. So T equal to 2L by A root over. Now in this case, A will be replaced by what? This net acceleration, which is nothing but 3A plus mu g root over. So this is the answer. After this time, they are going to